Welcome to our journey into artificial intelligence, or AI. In this video, we'll explore what AI really means, its goals, the different types, and how it's shaping our world. Whether you're curious about how machines can think or you want to understand the technology behind digital assistants and self-driving cars, you're in the right place. We'll start with the basics, move through the history and foundations, and finish by weighing the advantages and disadvantages of AI. Let's begin by understanding what artificial intelligence is and why it matters in today's world. Artificial intelligence is a term made up of two words, artificial meaning man-made and intelligence, which refers to the ability to think, learn, and solve problems. In essence, AI is about creating machines that can mimic human thinking and decision-making. It's a branch of computer science focused on building systems that can behave and think like humans. When a machine can learn, reason, and solve problems, it's demonstrating artificial intelligence. This means AI isn't just about following instructions, it's about machines developing their own ways to approach and solve tasks. Like traditional programming, where every task must be explicitly coded, AI systems use algorithms that allow them to learn and make decisions on their own. This means you don't have to tell an AI exactly what to do in every situation. Instead, you create a system that can learn from data and experience, adapting its behavior over time. For example, AI can recognize objects and images, understand speech, or make decisions in complex environments. This learning process is inspired by how humans think, learn, and solve problems, making AI a fascinating blend of technology and psychology. Understand AI, it's important to know what makes up intelligence. Intelligence involves several key abilities: reasoning, learning, problem-solving, perception, and linguistic intelligence. Reasoning helps AI draw conclusions, learning allows it to improve over time, and problem-solving lets it tackle new challenges. Perception is about interpreting the world through senses, while linguistic intelligence enables understanding and using language. Together, these elements form the foundation of what we consider intelligent behavior, both in humans and in machines. Intelligent systems, whether human or artificial, share certain characteristics. They can communicate with other agents in their environment, use vast amounts of knowledge, and learn from experience. These systems adapt to changing conditions, interact with humans using language and speech, and respond in real time. Importantly, they can tolerate errors and ambiguity in communication, making them robust in complex situations. These traits are what make AI systems effective in real-world applications, from digital assistants to autonomous vehicles. Primary goals of AI are ambitious and far-reaching. First, AI aims to replicate human intelligence, enabling machines to think, reason, and learn like people do. Second, it seeks to solve knowledge-intensive task problems that require expertise in complex decision-making. Third, AI strives to create an intelligent connection between perception and action, allowing machines to sense their environment and respond appropriately. These goals drive the development of smarter, more capable AI systems. AI's goals go beyond theory. They're about building machines that can perform tasks requiring human intelligence. This includes proving mathematical theorems, playing chess, planning surgeries, or driving cars in traffic. AI systems are also designed to learn new things independently, explain their decisions, and assist users effectively. These capabilities are what make AI such a powerful tool in fields ranging from healthcare to transportation. AI can be categorized based on its capability. The first type is narrow AI, also known as weak AI. These systems are designed for specific tasks and can't operate outside their domain. Think of Siri, Google Translate, or spam filters. The next level is general AI or strong AI, which would be capable of performing any intellectual task a human can do. This remains a future goal. The most advanced, super AI, is still hypothetical, machines that surpass human intelligence, capable of creativity and emotions. For now, this exists only in theory and science fiction. AI can also be classified by functionality. Reactive machines are the simplest, they respond to specific inputs but have no memory. IBM's Deep Blue chess computer is a classic example. Limited memory AI can use past experiences for short-term decisions, like self-driving cars analyzing road conditions. Theory of mind AI, still under research, would understand emotions and social interaction. The most advanced self-aware AI is purely hypothetical and would possess consciousness and self-awareness, existing only in science fiction for now. There are four main approaches to understanding and developing AI. Some focus on how machines think, while others look at how they act. On one side, success is measured by how closely machines mimic human performance, while on the other, it's about achieving ideal, rational outcomes. These approaches help researchers and engineers design AI systems that are either modeled after human behavior or aimed at perfect logical reasoning. Thinking humanly approach, also known as cognitive modeling, tries to understand the internal workings of the human brain. The goal is to study how people think and behave in different situations, then design computers to replicate that behavior. Researchers use introspection, psychological experiments, and brain imaging to understand human thought processes. If an AI system's behavior matches human responses, it suggests the underlying mechanisms are similar. This approach is about making machines that think like us, not just act like us. Acting humanly approach is best illustrated by the Turing test, proposed by Alan Turing in 1950. The test asks whether a machine can behave intelligently, indistinguishable from a human in conversation. If a human interrogator can't reliably tell the difference between a human and a computer, the machine is considered intelligent. This approach focuses on outward behavior. Can machines act like humans, especially in language and reasoning? Past the Turing test, computer needs several key capabilities. It must process natural language to understand and communicate in human languages. It needs knowledge representation to store and use information, automated reasoning to answer questions and draw conclusions, and machine learning to adapt and improve. Additionally, computer vision and robotics allow it to perceive and interact with the physical world. These combined abilities are what make a machine appear truly intelligent. Thinking rationally approaches based on the laws of thought, a concept dating back to Aristotle. Here, a system is rational if it reasons correctly, always doing the right thing given the information it has. For example, if all men are mortal and Abdi is a man, then Abdi is mortal. This logical approach forms the basis of much of AI's early development, focusing on creating systems that can reason and draw valid conclusions. While thinking rationally sounds ideal, it comes with challenges. First, it's not easy to translate informal, uncertain knowledge into strict logical rules. Second, there's a big difference between solving a problem in theory and actually doing it in practice. Building AI systems that can reason logically, especially with incomplete or uncertain information, remains a significant challenge for researchers. Acting rationally approach centers on rational agents, systems that do the right thing to achieve their goals given their beliefs. Most modern AI research focuses on building such agents. This approach is broader than just following logical rules. It includes any method that helps the agent act rationally. It's also more scientific, allowing for measurable progress and improvement. Rational agents are at the heart of today's AI systems, from recommendation engines to autonomous vehicles. Rational agents offer two main advantages over other approaches. First, they're more general. Correct inference is just one way to achieve rationality, but not the only one. Second, this approach is more amenable to scientific development, making it easier to measure and improve AI systems. By focusing on rational agents, researchers can build systems that are flexible, adaptable, and effective in a wide range of real-world situations. Build intelligent machines, we need to understand the foundations of intelligence itself. Intelligence is a combination of reasoning, learning, problem-solving, perception, and language understanding. For a machine to exhibit these traits, AI draws from several academic disciplines, each contributing unique insights and methods. Let's explore these foundational fields and see how they shape the development of AI. Philosophy asks deep questions about knowledge, reasoning, and the mind. Can formal rules be used to draw valid conclusions? How does the mind arise from the brain? Mathematics, on the other hand, provides the formal rules for reasoning and computation. It helps us understand what can be computed and how to deal with uncertain information. Together, these fields lay the groundwork for logical thinking and problem-solving in AI. Economics teaches us how to make decisions to maximize payoff, even when outcomes are uncertain or others may not cooperate. Neuroscience studies how brains process information, offering insights into how intelligence might be replicated in machines. By understanding decision-making and brain function, AI researchers can design systems that learn and adapt, just like living organisms. Ecology explores how humans and animals think and act, providing models for intelligent behavior. Computer engineering focuses on building efficient computers, the hardware that makes AI possible. For AI to succeed, it needs both intelligence and a physical or digital artifact to embody that intelligence. These fields ensure AI systems are both smart and practical. Control theory and cybernetics study how systems can operate under their own control, essential for autonomous AI. Linguistics examines how language relates to thought, helping AI systems understand and generate human language. Together, these disciplines enable AI to interact with the world and communicate effectively, bridging the gap between machines and people. AI is truly interdisciplinary, drawing from philosophy, mathematics, economics, neuroscience, psychology, engineering, control theory, and linguistics. This blend of fields allows AI to tackle complex problems, learn from experience, and interact with humans in meaningful ways. By combining insights from so many areas, AI continues to evolve and expand its capabilities. AI is more than just a technological trend, it's a tool for solving real-world problems. With AI, we can create software and devices that address challenges in healthcare, marketing, traffic management, and more. Personal virtual assistants like Siri and Google Assistant are powered by AI, as are robots that work in hazardous environments. AI also paves the way for new technologies and opportunities, making it a driving force for innovation. History of AI is rich and varied, with roots in philosophy, mathematics, and computer science. Over the decades, AI has evolved from simple rule-based systems to complex learning algorithms. Today, AI can drive cars, recognize speech, plan logistics, and even play games at a superhuman level. This journey reflects both technological progress and our growing understanding of intelligence itself. Modern AI systems are capable of impressive feats. Robotic vehicles navigate city streets, speech recognition systems transcribe conversations, and AI plans complex logistics for businesses. Spam filters keep our inboxes clean, and machine translation breaks down language barriers. These applications show just how far AI has come and hint at even greater possibilities in the future. AI is everywhere, touching nearly every aspect of our lives. In agriculture, it helps optimize crop yields. On social media, it curates content and detects fake news. In healthcare, AI assists with diagnosis and treatment planning. Data security, education, travel, finance, robotics, gaming, entertainment, and the automotive industry all benefit from AI-driven solutions. The impact of AI is broad and growing every day. One of AI's biggest advantages is its high accuracy and low error rate. AI systems can process vast amounts of data quickly, making decisions with speed and precision. They're highly reliable, able to perform the same action repeatedly without losing effectiveness. In risky situations like bomb disposal or deep-sea exploration, AI can take the place of humans, reducing danger and improving outcomes. AI powers digital assistants that make our lives easier. E-commerce websites use AI to recommend products tailored to your preferences. Virtual assistants like Siri and Google Assistant help with daily tasks, while AI-driven systems provide personalized support and information. These digital helpers are becoming more sophisticated, offering convenience and efficiency in both personal and professional settings. AI is increasingly used in public utilities, making life safer and more convenient. Self-driving cars promise safer journeys, while facial recognition enhances security. Natural language processing powers search engines, spelling checkers, and translation tools. These applications demonstrate how AI can improve everyday experiences in public services. Despite its benefits, AI comes with significant costs. The hardware and software required for advanced AI systems are expensive, and ongoing maintenance is needed to keep up with changing demands. These high costs can be a barrier to widespread adoption, especially for smaller organizations or developing regions. AI systems, no matter how advanced, can't truly think outside the box. They excel at tasks they're trained for but struggle with novel or creative challenges. Unlike humans, AI lacks imagination and the ability to generate original ideas. This limitation means that, for now, creativity remains a uniquely human trait. AI machines can perform tasks with incredible efficiency, but they lack feelings and emotions. This means they can't form emotional connections with humans, and their decisions may sometimes seem cold or insensitive. In situations where empathy or understanding is needed, AI falls short, highlighting the importance of human involvement. As AI becomes more integrated into our lives, people are increasingly dependent on machines. This reliance can lead to a decline in mental capabilities as we outsource more tasks to technology. While AI offers convenience, it's important to maintain a balance and continue developing our own skills and abilities. While AI can process information and solve problems, it lacks the originality and creativity that humans possess. Humans can imagine new ideas and create art, music, or inventions from scratch. AI, on the other hand, is limited to what it has learned and cannot truly innovate in the same way. Sum up, AI offers many advantages: high accuracy, speed, reliability, usefulness in risky situations, digital assistance, and public utility. However, it also has drawbacks, including high costs, limited creativity, lack of emotions, increased dependence on machines, and a lack of originality. Understanding both sides helps us use AI responsibly and effectively. AI's influence is expanding rapidly, touching industries from healthcare to entertainment. As technology advances, AI will continue to shape the way we live and work. It's important to stay informed about AI's capabilities and limitations so we can make the most of its benefits while addressing its challenges. With great power comes great responsibility. As AI becomes more capable, ethical considerations become increasingly important. Issues like privacy, bias, and accountability must be addressed to ensure AI is used for the greater good. Developers, users, and policymakers all play a role in guiding AI's development in a positive direction. AI is transforming the workforce, automating routine tasks and creating new opportunities. While some jobs may be replaced, others will emerge, requiring new skills and adaptability. Lifelong learning and flexibility will be key to thriving in an AI-driven world. Embracing change and upskilling can help individuals and organizations stay ahead. Education is one area where AI is making a big difference. Intelligent tutoring systems, personalized learning platforms, and automated grading are just a few examples. AI helps tailor education to individual needs, making learning more effective and accessible. As AI continues to evolve, it will play an even greater role in shaping the future of education. Healthcare is another field benefiting from AI. From diagnosing diseases to planning treatments and managing patient data, AI is improving outcomes and efficiency. AI-powered tools assist doctors in making accurate diagnoses and predicting patient needs. As technology advances, AI will continue to revolutionize healthcare, making it more precise and patient-centered. Transportation is being transformed by AI, from self-driving cars to smart traffic management systems. AI helps optimize routes, reduce accidents, and improve fuel efficiency. Autonomous vehicles are becoming more common, promising safer and more convenient travel. As AI technology matures, transportation will become even more efficient and accessible. Entertainment is another area where AI shines. From recommending movies and music to creating realistic video game characters, AI personalizes and enhances our experiences. Content creators use AI to generate music, art, and even scripts, pushing the boundaries of creativity. The entertainment industry will continue to evolve as AI becomes more integrated. Security systems are leveraging AI to detect threats, prevent fraud, and protect data. Facial recognition, anomaly detection, and predictive analytics are just a few examples. AI helps organizations stay ahead of cyber threats and respond quickly to incidents. As security challenges evolve, AI will play an increasingly vital role in keeping us safe. As we look to the future, AI will continue to shape our world in ways we can only imagine. Its potential is vast, but so are the challenges. By understanding AI's foundations, applications, and limitations, we can harness its power responsibly and creatively. The journey of AI is just beginning, and its story is one we all share.